All right, the 2.1 worksheet problem number 3 here is asking you to find the equation of a secant line that passes through these two particular points here on this curve. Now, truthfully, even though they give you the graph of this overall function right here, and they've given you the definition of it, none of this is really relevant anymore to this problem. They're asking us to find the equation of a secant line, and a secant line is a line defined by 2 points on a curve. So here's a point right here, -2, -4. Here's a second point, 1, 2. Really, none of this is relevant anymore. All that matters is that we're finding the equation of the one and only line defined by those 2 points on a curve. The only thing you really could do, if you cared, is make sure that these y values are correct given these x values, but I'm sure that they are. -2 squared is 4, the opposite of which is -4, plus -2 is -6, -6 plus 2 is -4. So that one checks out. And when x is 1, you get -1 plus 1, which is 0, plus 2, which is 2. That one checks as well. I wouldn't think they would lie to you. These 2 points are both correct and being located on this curve. So here we go, guys. First thing we needed was the slope of our secant, and that is just the formula for slope between these 2 points. So I'd go with 2 minus -4, so 2 plus 4. And then in the denominator, 1 plus 2. So that's going to get us a 6/3. So they were nice to us here and gave us a whole number for the slope. Now that you've got the slope of your secant, let's go to point slope form using either one of those 2 points. But I would imagine most of us would choose this one here because it's got positive coordinates. Easier to work with than negatives. So y minus your y coordinate is equal to your slope, 2, which we just came up with right here, times x minus the x coordinate, which is 1. So 2 steps and we're done, guys. Y minus 2 is now equal to 2x minus 2. Oh, and we'll add that 2 to the other side and just come up with y is equal to 2x, and that is our answer. Find the equation of the secant line that intersects those 2 points. Now, real quick, just to satisfy us here, your curiosity, to make sure that we got this right, the graph was given to you on this function, and I'm just going to eyeball it here real quick, guys. It looked like, let's see, it was a parabola opening downward, and its vertex was maybe like about here somewhere, and I don't know, guys, it did something like this, and it did something like this, and these 2 points of secancy, not surprisingly, should be points on the curve. -2, -4 looks like it was maybe here somewhere. And then the point 1, 2, was just to the right of the vertex. It was maybe right about there. So I tell you what, I should have done those in red. This point and this point right here, those are the 2 points of secancy. There is only one line that passes between them, and that line would look something like this. So the only question I would ask you guys now is, does it look realistic that that red secant line that I just drew right there is the line y equals 2x, meaning a line with a slope of 2 and a y-intercept of 0. Obviously, I just drew this graph by hand, so it wasn't very accurate, but on your worksheet, you guys have the exact graph on there. I think if you plotted those 2 points and carefully, using a ruler or a straight edge, drew the line between them, I think you'd find that that answer looks really realistic, and therefore I feel pretty good about our answer to this problem.